Hello, everyone. Welcome again to CUTRIC's second annual Zero Emissions Bus Technologies and Transit Operations Conference. Before we begin, I'd like to share that we've got closed captions available in both English and French. You can enable this tool by clicking directly below the video stream. By the way, my name is Soumya Bhausar. I'm project manager on the Pan-Canadian Hydrogen Fuel Cell Bus project at CUTRIC. And it's my pleasure to welcome you to our first panel on hydrogen transit, innovating a local green hydrogen solution for fuel cell buses and fueling technologies, wherein we will discuss about innovating a local green hydrogen value chain using hydrogen buses. I'm joining you today from Calgary, Alberta, and in the spirit of reconciliation, we acknowledge that we live, work, and play on the traditional territories of the Blackfoot Confederacy, including Siksika, Kainai, Piikani, the Tsuut'ina, the Îyârhe Nakoda Nations, the Métis Nation Region 3, and all people who make their homes in the Treaty 7 region of Southern Alberta. I'd also like to thank our gold sponsor, HDR, for sponsoring this panel. Well,
in my opinion, the best technology is invisible, right? So it's not a matter of the public accepting it or not accepting it. For example, when you ride in your first automated vehicle, everybody gets real nervous and this thing's gonna drive itself and is it gonna really stop? And after you get out, you're like, okay, yeah. I mean, and that's the way technology should be. There's not a mode out there where technology is not emerging rapidly. We've seen cars get smarter, we've seen the roadside equipment get smarter, and we're on that acceleration curve in terms of technologies. What we have to try to do for our clients that they may not think about is prepare them for technologies without knowing exactly what technologies we're talking about. MOT stands for Mobility and Operational Technology Services, and what that really means is it's about technologies used for mobility, to move people and goods from place to place. There's these four technology areas that are starting to converge. That convergence means that the market is going to start to form around these four, and the whole point of MOTS is really to have that synergistic look at things. We don't want to just look at tolling, and we don't want to look at just connected automated vehicles, but we want to integrate this technology across everything HDR is doing. We're so immersed in technology in every other aspect of our life. Why not transportation? We've got experts that do all kinds of different technologies. I mean, we have one of the country's leading experts in wireless inductive charging in pavement. Who would have thought, right?
So yeah, I'd like to extend thanks again to HDR for sponsoring this panel. Let's do some quick introductions here. I'll introduce the panel and our panelists real quick. So we've recently completed the feasibility study for fuel cell buses. This feasibility study applies to Mississauga Transit MiWay. So we will be discussing challenges and successes encountered along the way of getting to this stage in the Pan-Canadian fuel cell bus trial. We've also got one of our team members on board. We basically got Parvathy Pillai from CUTRIC, who'll be on hand to present the predictive modeling results and aggregate summary results of the study. We'll then explore the funding and deployment challenges of procuring, deploying, and operating these 10 fuel cell buses as the next phase of the trial takes place. Our panelists here who have been champions of this project, who have supported this project over the last few years, will also highlight how they are prepared to collaboratively support projects like these and other interested transit agencies get buses on the ground going forward. And so introducing a panelist here, we've got, first of all, of course, Parvathy Pillai, who's Program Manager of ZEB Consulting Services and Business Development at CUTRIC. We've got Kirk Burka, who's Vice President of Engineering Services at New Flyer. We've got Nicolas Pocard, Vice President of Marketing and Strategic Partnerships at Ballard. And we've got Rob Harvey, who's Director of Energy Infrastructure at Cummins. That said, I will now pass over the mic to Parvathy to begin the panel presentation, and we'll take it from there.
Thank you so much, Soumya. Great to be here to present on innovating a local green hydrogen solution for hydrogen, FCEBs, and fueling technologies in this particular panel on the highlights on the MiWay predictive performance modeling project outcomes. So here I would like to start by giving a quick overview on our RODI 2.0 modeling tool that we have used for this particular predictive performance modeling study. RODI is our in-house Python-based, highly sophisticated tool set that has the prowess and capabilities to do predictive performance modeling, assessing the performance of the zero emission buses before they are launched and deployed on the roads. It would enable the transit agency to understand the actual electricity costs expected if they are reliant on green hydrogen, for example, as well. It can predict the state of charge of the battery on board the bus. It can predict the performance success rates, which we are going to be seeing for MiWay in a bit, the assessing the suitability for different routes and blocks or vehicles even for electrification, and consider the environmental business case involving the operational GHG emission reductions and the life cycle side of the equation as well. So quickly on the RODI 2.0 modeling tool, we have different aspects to this particular modeling tool. We start by looking at the topographical conditions prevailing at the transit agency and conduct a robust GIS modeling, considering the route profiles, the speed profiles, the traffic scenarios, and then we generate synthetic duty cycles considering different seasonal variations and ridership, and evaluate the performance of different modes of zero emission technology like battery or hydrogen, and conduct a charging analysis and refueling analysis as well. So this is the tool that we have used for conducting the analysis that we did for MiWay. And here, what I'm going to be talking about is the success rate for the fuel cell electric bus performance at MiWay. So we considered the entire fleet at MiWay for this particular analysis, and considered if the entire fleet at MiWay is transitioning to hydrogen and operating the fleet using hydrogen fuel cell electric buses, what is the fuel economy expected? So our analysis considered three operational scenarios involving weekdays, Saturday, and Sunday, because these are the three operational days that MiWay's fleet is operating, and then considered what the success rates are. When we talk about success rates, it's actually if the bus is exiting the garage at the start of the day with a full state of charge on their batteries, how much, what does it take for it to, complete the service requirements? If the battery state of charge on board the bus doesn't drop below the 20% mark, then we deem that particular bus or particular service successful. That is the success criteria with which we have analyzed this particular study here, and calculated the fuel economy to be 9.92 kilograms of hydrogen per 100 kilometers. This is comparable to other transit agencies that we have modeled in Ontario as well. But if you do look at the success rates that are shown on the y-axis in percentage, and on the x-axis you would see the 3 days of operation listed. You would notice in the case of weekday, we are seeing that without even a refueling episode happening during the day, if the bus exits the garage with a 100% state of charge and a full hydrogen tank, we are expecting close to 90% or even slightly higher than 90% success rate, which means that only 10% of the buses at MiWay would experience like a drop in their state of charge to below 20% mark, which would make them unsuccessful. In the case of Saturday and Sunday, the success rates are slightly lower than that because of the block design. So on weekends, and this is typical at many transit agencies, the number of buses would be lesser, which means that the existing buses would be expected to cover a longer range, and sometimes that may have like direct effects on the performance success rates, which we are seeing right here. But if the buses are enabled to have one refueling episode during the day, these problems would be resolved. here we are trying to establish the environmental business case from the operational standpoint here. So if the full fleet at MiWay is electrified using electrolytic hydrogen, which is the green hydrogen, the total GHG emission reduction expected is close to the 93% mark, which means that this bold green bar that we see here is well below that 5,000 tons mark, whereas the diesel is above the 70,000 mark. So this is the actual information that we obtained from MiWay based on their annual diesel consumption and translated it into the operational GHGs in tons carbon dioxide equivalent per year. And you would notice the decline that fuel cell electric buses powered using green hydrogen makes for MiWay's fleet and the community. In terms of cost estimations, we have compared the diesel cost that MiWay pays with two hypothetical price estimations here. One is the $5 per kilogram for the hydrogen that MiWay would be using, or $15 per kilogram for the hydrogen. This is electrolytic hydrogen, covering all the costs associated with it, making it comparable to diesel in terms of all costs covered. And we would notice that if the cost of hydrogen is at the $5 per kilogram mark, the actual expected operational cost of fueling in terms of fuel cost would be lower than that of diesel. But of course, with the higher price point, the price is expected to increase as well. So the actual price that MiWay is paying is a proprietary information, but here these are the hypothetical scenarios that we have listed to compare between the two scenarios of hydrogen pricing with diesel. And with that, I would like to thank you for listening, and I'm open to any questions you may have in the Q&A period. Back to you, Soumya.
Thank you, Parvathy. So yeah, that was a great insight into the rationale for the technology and the success rates and the emissions reductions that are possible using fuel cell buses. Now on stage, I'll have Kirk Burka from New Flyer. Kirk is Vice President of Engineering Services at New Flyer. And Kirk would love to tell us a bit more about New Flyer's experiences with fuel cell bus deployments across North America.
Yes, thank you very much. I very much would. So hello, everybody, and welcome. I'm very happy to be here today with this panel. And as stated, I'm the Vice President of Engineering Services for the NFI Group, a leading independent global provider of sustainable bus and motor coach solutions that includes both New Flyer as well as Motor Coach Industries. Today, we provide 4 pillar mobility solutions, including first, buses and coaches, connected technology, infrastructure, and fourth, and just as importantly, workforce development, driven by nearly 8,000 people across 9 different countries. So once again, thanks to CUTRIC for hosting this conference and facilitating these very important ongoing discussions, and for inviting me and my New Flyer colleagues. I'm very much looking forward to the panel, and again, very pleased to be here. Our journey, well, let me find the button here. Our journey now, our fuel cell journey, began way back in 1993 with prototype technology, working very closely with our partners at Ballard, followed shortly thereafter with a 20-bus evaluation program for the 2010 Olympics, which really helped the stage for our current generation of hydrogen vehicle platform. In 2018, we delivered the first 60-foot zero-emission fuel cell bus in North America. And in 2019, we introduced the xcelsior Charge H2 fuel cell electric bus. And even later that month, one of those buses with Orange County down in the US was able to surpass a range of 482 kilometers without refueling under a very rigorous test environment. So ultimately it reached, using battery as well, 564 kilometers, and we're very proud of that demonstration. Finally, earlier this year, more recently, we announced New Flyer, NFI, as a founding member of the Hydrogen Fuel Cell Bus Council in the US, which is focused on advocating for and advancing the adoption of fuel cell buses at scale in the US. We have long believed in the power of hydrogen fuel cell technology, and we're finally seeing the interest really ramp up in our market. Today, our fuel cell buses using Ballard fuel cells have been deployed with some of the most notable, oh, my apologies, as I jump screens here repeatedly. Today, our fuel cell buses using Ballard fuel cells have been deployed with some of the most notable zero-emission leaders in the US, including AC Transit, Sunline, Orange County, and Champaign-Urbana. And if you tune into tomorrow, our president, Chris Stoddard's panel on fuel cell electric bus pilot program efforts across Canada, you'll hear more about some of the exciting orders we've received over the past year. Now, a little more on our fuel cell electric bus for those that are unfamiliar. And I know Mike McDonald touched on some of this earlier, but let me elaborate ever so slightly. New Flyer's Xcelsior Charge H2 is a battery electric vehicle using compressed hydrogen as an energy source. The fuel cell electric technology is a unique and innovative way to extend the range of a battery electric bus. So we've created our fuel cell electric bus by applying modern fuel cell technology to our proven xcelsior platform, a platform that has had more Altoona tests than any other platform in the industry, leveraging more than 50 years of our experience designing high voltage electric trolleys and hybrids, and over 20 years of experience designing, testing, and deploying fuel cell buses for North American operators. Our hydrogen fuel cell electric Xcelsior Charge H2 heavy duty transit bus offers benefits such as extended range, which I've already touched upon, providing over 500 kilometers on a single refueling with no offboard electric recharging. Fast fill times ranging from 6 to 20 minutes, depending on the bus model and the operating config. Immediate greenhouse gas reduction, as touched upon earlier, estimated at 85 to 135 tons of emissions saved per year compared to a diesel. And finally, fuel cell rejected heat is captured through a heat exchanger to supplement the HVAC system. So there should be minimal impact to range reduction at colder ambience, which is especially appealing here in Canada. As mentioned, fuel cell technology is nothing new, but has been gaining popularity in recent years. And very recently, in October of last year, our customer Champaign-Urbana, located in Illinois, unveiled America's first 100% renewable hydrogen fleet. This fleet features our fuel cell electric Xcelsior Charge H2 vehicles and are refueled with 100% renewable hydrogen supply powered by solar energy. The only output of these buses is water. And yes, Paul Soubry really did drink from the emissions of that vehicle. Since 1993, New Flyer has delivered nearly 200 traditional and H2 buses to Champaign-Urbana, and we're thrilled to have been selected to support their game-changing deployment of hydrogen technology. We look forward to many more success stories such as this, and we're very excited for what's about to roll out here with Mississauga and Winnipeg with MiWay and Winnipeg Transit. To provide a brief update and some background, MiWay began a feasibility study with CUTRIC and other partners back in April of 2021, and it's on track to be completed in April of this year. The study aims to deliver life cycle, energy, emissions, and economic performance analyses on New Flyer's fuel cell electric buses, along with a preliminary roadmap for MiWay on their journey towards zero emission adoption. MiWay's initial fuel cell bus deployment project will be the first Canadian Xcelsior Charge H2 trial of this size and represents a greater opportunity for Mississauga to be a national leader in innovative clean technology. We're very thrilled to be chosen as a partner for this program, for this trial. With our zero emission Xcelsior Charge H2 fuel cell electric bus, we will help lower greenhouse gas emissions and provide positive impacts to the hydrogen ecosystem in Ontario. These actions, there's two primary goals for the introduction of fuel cell electric buses at MiWay, as outlined in the CUTRIC feasibility study. And those are, number one, to develop environmental responsibility, and number two, to lead and encourage environmentally responsible approaches. And these actions are very much in line with New Flyer's commitment to a greener world and the sustainable evolution of mobility. We're also very excited to partner with the City of Winnipeg on a fuel cell pilot in the future. As stated in Winnipeg Transit's transition to zero emission, its technical evaluation report will help identify the decision on which technology best suits Winnipeg. But this is highly dependent on many factors, such as the current transit operations and local sources of electricity and hydrogen. Since Manitoba's energy mix is 99% renewable, this creates a unique opportunity for Winnipeg Transit to potentially operate both battery electric and fuel cell battery electric buses from renewable sources at costs significantly lower than other cities in North America. Again, to hear more on Winnipeg's move to zero emission, I encourage you to attend tomorrow's session featuring our own Chris Stoddard, as well as Winnipeg Transit's Aaron Cook. So in closing, at New Flyer, we believe that fuel cell electric and battery electric propulsion are an ideal complement, but that will see a significant growth in fuel cell adoption over the coming years. Like any major decision in transit operations, the right option for you will be highly dependent on your agency's operating conditions and needs. We're excited to see the growing interest in fuel cell electric technology in our industry and are ready and willing to help agencies with their zero emission deployment opportunities. Thank you, and I'm very much looking forward to today's discussion.
Thanks a lot, Kirk. That was quite the overview of the North American landscape, and it is exciting to learn more about New Flyer's experience in the fuel cell bus space. With that, I would also like to, I'd now like to invite Nicolas Pocade on stage. Nicolas is Vice President of Marketing and Strategic Partnerships at Ballard. And Ballard, alongside New Flyer, are a very important project partner on the Mississauga bus deployment, as well as many other fuel cell bus deployments and fuel cell technology deployments across the world. Nicolas, the stage is yours.
Thank you very much, Sonia, and thank you very much for the invitation. Very happy to be speaking at the CUTRIC Zero Emission Bus Conference today. And we have at Ballard been part of the fuel cell venture for a long time and working closely with our consortium partners here today and with CUTRIC to really advance the deployment of hydrogen mobility across in Canada. So at Ballard, our venture in fuel cell started more than 40 years ago. At Ballard, this is the only thing we do. We don't have any other technology. We don't have any other, activities. The company for the past 40 years has been devoted to advance hydrogen mobility. So today, our mission is to deliver fuel cell power for a sustainable planet. We have over 1,100 employees globally, which are supporting that mission. And we do that through our unique fuel cell expertise. Today, we deliver fuel cell products ranging from tens of kilowatt to megawatt for stationary application, but up to 200 kilowatt in mobility. Very clear focus today for Ballard on heavy-duty mobility, so bus, trucks, rail, and marine. But also what's very important is our customer care. We stand by our products, we stand by our customer, we work with our partners like New Flyer in order to make sure that the early adopters of fuel cell electric mobility will have the best experience, the maximum uptime on the vehicle, as well as making sure that we understand the customer feedback and that feeds into our product development roadmap. But also, we are looking at not only just providing a product, but really a solution, work with our OEMs, partners to better integrate the fuel cell in the electric, hybrid, battery powertrain, so we can optimize the vehicle performance and decrease the hydrogen fuel cell hydrogen consumption while improving the range and the overall performance of the vehicle. So that's our mission. That's what we do, and that's how we serve hydrogen mobility and towards a goal of a decarbonized transportation sector. So, as mentioned earlier, I think we started our venture in fuel cell bus in the mid-90s with New Flyer when you put the first fuel cell bus on the road. Since then, we are today powering over 1,600 transit buses in the world. So that's the bus which are actively operating today. And we have clocked over 100 million kilometers in bus and truck operation at Ballard. So we have this unique expertise and how fuel cell will behave in different climate. We have buses in operation in very cold climate in Norway or in some northern part of soon coming in Edmonton. But also in very hot climate, like in Palm Springs, where it could be, over 40 degrees C during a long period of time. So we know how fuel cell works. We know how fuel cell operates. We have operated a fleet of close to 10 buses in London for 10 years. And we have shown that fuel cell is durable. All the fuel cell in those bus program lasted over 25 to 30 and even 35,000 hours. So we have proven that, beyond just initial demonstration, fuel cell can operate in a lot of different conditions over a long period of time without compromise in operation. And at Ballard, we stand by our technology. So we offer extended warranty to our products, 6, 12 years, up to 1 million kilometers, depending on the requirement of the contract. But we believe in our technology. We stand by our product. We stand by our customers, and we deliver the best performance. But what has been very important lately is really where we see the increase of adoption of fuel cell. I don't know. I've lost my slide. I don't know. Can see. Okay, don't know. Cannot see the slide now, so I don't know if you can see my slide or not. But seems to be. Don't know what is happening here. Anyway, so just trying to show that today there are over 1,600 fuel cell buses powered by Ballard, and we have seen the acceleration in demand for transit agency in North America, in Europe. There is over 80 fuel cell buses in operation in the US. There are over 190 fuel cell electric buses in operation in Europe, and that number is growing very rapidly. As of Monday, the Transit Authority in the UK, in the Midlands, have announced a deployment on a funding of 124 fuel cell buses around the Birmingham region. 100 of them are going to be double-decker buses, and 24 of them are going to be articulated buses. So we start to see the acceleration in demand as transit agencies are saying that they need more than one solution. You need both battery electric and fuel cell electric if you really want to achieve the 100% zero emission bus fleet. Both technology works together. They complement each other depending on the routes, depending on the depot, depending on the energy availability. You're going to need both technology in order to achieve this 100 zero emission deployment. And lastly, just wanted to share with you as on my last slide, the view that we have on the and some of the, sorry, just trying to just a bit of a problem with the slide here. Yeah, sorry, just here, just to finish up, is really a report which has been done, ongoing study done by AC Transit, where they're comparing the operation of 5 diesel buses, 5 diesel hybrid, 5 battery electric, fuel cell electric, new generation with the new Flyer buses, and the older generation, which was built 12 years ago. And what it shows actually today that fuel cell electric buses are a very viable option. They perform like also buses in a cost. Operating cost of the fuel cell buses actually is very attractive. As those buses are being deployed on the fuel cell battery electric, I think they are being, the availability is lower than the one of the diesel and diesel hybrid, but as all of has to do with the teething of the early deployment of the program. We expect those availability numbers to become higher. Today, even fuel cell electric bus is getting very close to CNG, to diesel hybrid, and should be getting close to the diesel. And we are seeing in other fleets in Europe today that the availability of fuel cell electric buses is very similar to the one of diesel buses. And the fuel cell itself, the powertrain availability is above 97 to 98%. So it really shows today that fuel cell electric buses can operate in your fleet like any other buses, and then they will enable that transition to a full zero emission bus fleet without any compromise in service and without having the need to increase drastically the numbers of vehicles. And a combination of both battery electric and fuel cell electric will enable that successful deployment of zero emission fleets across Canada. Thank you very much for your time.
Thank you, Nicolas. And so yeah, it's quite the message, quite the reinforcement of a core message that fuel cell bus technologies are an important complement to battery electric bus technologies and can play a critical role in your zero emissions bus fleet. Also reassuring, based on Nicolas and Kirk's presentations, that the technology is here. But The last piece of the puzzle in a fuel cell transit value chain, of course, the fuel, and especially clean hydrogen, a very important piece, of course, to rationalize hydrogen buses in the first place. To talk a bit about the fuel supply side, we've got Rob Harvey, who's Director of Energy Infrastructure at Cummins. Rob can shed some light on solutions available for green hydrogen supplies, not just in Canada, but across the world as well, and how Cummins plays a vital role there. Rob, the stage is yours.
And appreciate the invitation to be on this panel. Like the other CUTRIC MiWay consortium partners, New Flyer and Ballard, I'll be talking in terms of Cummins' role today, but also Enbridge. Enbridge and Cummins are the part of the for this consortium, providing a green fueling infrastructure and fuel supply for those 10 fuel cell electric buses in this demonstration trial. I'd like to give a bit of an introduction to Cummins and some of the work that we do both on the fuel cell side and on the green hydrogen production side. Just to give a bit of a background and the overlay of the spaces, market spaces that we play in. This is the new power applications on the top there. Battery electric buses. We do Bluebird school buses. We do fuel cell buses. Actually, I put that in the wrong line here. The UTOG is the biggest bus manufacturer in China, and we've supplied fuel cell power modules for hundreds of their buses. We do a lot of work with OEMs in other spaces, heavy-duty trucks. That's an example of Scandia trucks for food delivery in Norway, Kradia Island, and also on electrolyzers. So we work both in the fuel cell and the electrolyzer space, and we've done a number of projects. You see number 4 there. That is a picture of the Markham Energy Storage Facility on Enbridge's Technology and Operations Center located in Markham. That's a plant that's 2.5 megawatts that's been operating since 2018. And that, in fact, is the site of the hydrogen production that we're going to be using for the MiWay fuel cell electric bus project. We've also been involved in larger scale projects. I'll be talking about that, Air Liquide on number 5 at the bottom there. And we've done electrolyzers and compression storage and dispensing for a number of fueling stations around the world. Let's start with fuel cell solutions with OEMs. This is a picture of a Gillig fuel cell electric prototype bus that we've worked with to develop with Gillig, and our fuel cell architecture is a low pressure design, and there's a number of advantages to our design. One is there's no need for humidification. I think I love that slide that Kirk showed with the Maryland executive drinking the water that came out of a fuel cell. Indeed, that is the only emission from a fuel cell electric vehicle is water, and it makes sense if that water is being produced that we could use that for humidifying the membranes, the magic part of a fuel cell that makes it work, and we use that water for. There's no external humidification required with our design. Size and weight. Our fuel cell power modules are about half the weight and size as a high pressure system on a 30 kilowatt comparison. And another important distinction is our air delivery system. And again, this is part of the low pressure design. We do not have a compressor in our system. We just need a small air blower and a compressor. As you know, anything with compression tends to be a higher cost maintenance item, and we have 5 times longer lifetime with our system for the blower. The other capability is a freeze capability. Our systems are designed for sub-zero systems. A lot of those buses that were deployed in China are north of the Yangtze River and have winters much like ours, and you can freeze our system without additional components. Did I get my conferences mixed up? No, this isn't the CUTRIC Smart Rail conference. The reason I'm just quickly mentioning the train, this is, we supply the fuel cell compositions. You can see there for Alstom, for the Craddy Island. That's the world's first zero emission commuter train. It's just to say all those advantages that I just talked about in terms of the Hydrogenics, the HD30 fuel cell power module, and in the composition that you see here, really come to fare where you have limited space, you've got high vibration, a very challenging environment for a fuel cell running on a train, and the packaging there you see there is for a 200 kilowatt design. So the fuel cell, all the hydrogen management, all of the water management, the electrical, and all those systems, we package, and actually we build those in our Mississauga facility here in Ontario for Alstom for that project. Shifting gears here, I want to talk about fueling solutions and green hydrogen. And as Shamo mentioned, one of the attractions for fuel cell is obviously the emissions. And if we can use green hydrogen and produce hydrogen from water in places like Ontario and Quebec and BC and Manitoba, we're going to have zero emission hydrogen, and it'll carry through on that supply chain. I'm going to talk about three types of applications that we see evolving. One is on-site fueling solution. This is a picture of the first public fueling station in Quebec. It's it's run by Harnois in Quebec City, and we supplied the electrolyzer and the compression, storage, and dispensing for this station. On the top left there, you see a picture of a HiStat 100, and that's basically a 200 kilogram a day facility in terms of capacity output. It's a small containerized solution and is appropriate for a smaller on-site location. The second one is a distributed gas as a service fueling network model. And this is an example of a project called High Balance in Denmark, where we supplied electrolyzers, and the total consortium added the compression, high pressure storage, and in this project, filling tube trailers for delivery to fueling stations. And this is like the model that we're looking at for the MiWay project. The gas as a service would be done by the Markham Energy Storage Facility. We would fill large capacity tube trailers for delivery to MiWay's bus depot. And then when those trailers are empty, we would swap them with a full trailer. This is an example of the Hylizer 500. This is our workhorse turnkey PEM electrolyzer system, and it's 1,000 kilograms a day. So when you think about an application with buses, if you had 30 buses, if you had a Hylizer 500, which is two 40-foot containers, it's very small footprint, you could do 30 buses. If you had two of these units, you could do 60 buses. And finally, is a hydrogen hub. When you think about large-scale centralized production and possibly liquefaction, you need a bigger unit. And this is our indoor Hylizer 1000. And this is the Air Liquide. This site in Bécancour is a 20 megawatt project, 8,000 kilograms per day of green hydrogen. It's the largest PEM electrolyzer plant in the world. So we have solutions for on-site, for distributed gas as a service, and hydrogen hubs to help develop a green hydrogen infrastructure for fueling buses and trucks and other vehicles. Thank you.
Thank you, Rob. That was definitely a very important final piece of the puzzle. And yeah, I'd like to welcome everyone on stage. Thank you for the engaging presentations. If we talk about the approach for the discussion, let's try to go through some of the last remaining technical, economic, financial challenges, how the stakeholders come together to resolve these challenges. And yeah, what do we need to do to finally get these buses off the ground, especially in Mississauga and at other transit agencies like Winnipeg and maybe other transit agencies in Canada. But yeah, if we start off, first of all, the most important question is, why is this project and other FCEB deployments, why are they important for your particular organization? So I'll do a quick round. It would be great to really understand what the strategic interests are for your organizations, and especially why this particular local deployment of fuel cell buses in Canada is important. Then we can nail down, what's really stopping us from getting there. So yeah, I'll start off with Nicolas. Nicolas, of course, Ballard being one of the global leaders in fuel cell technology. This particular project, especially a Canadian deployment, what is your strategic objective with it? Why is it so important?
Well, it's important because there will be, some of the first larger deployment in Canada since the Whistler projects back in 2010. And since that, the technology has evolved a lot. You can imagine in 12 years, electromobility in general has evolved a lot. So we had a very different generation of powertrain, electric drive, and fuel cell system and everything. I think it's important I think Canada is going to need hydrogen mobility in order to achieve decarbonization of transport and transit. We're not going to be able to do 100% electrification with battery electric vehicle for all the heavy-duty mobility. So both are going to be needed. And so I think those initial projects like Mississauga or Winnipeg or Edmonton are very important just to prove to Canadian Transit Agency that it's also working in Canada. It's working everywhere. So there's no reason why you shouldn't be working in Canada, but I think it's always important there's a local, program requirement. I think the weather in Canada is very challenging and the roads condition can be very challenging. So I think those products is very critical to show to other transit agencies across the country that it is also a part of the toolbox that they have to achieve that decarbonization.
For sure. And looking at the bus technology side, Kirk, anything you'd like to add to what Nicolas mentioned here?
Yeah, absolutely. I agree with Nicolas' statements. And, the fuel cell technology is ready. The bus technology is ready. It's been proven globally. It's been proven in the US. So I think what's very significant about the MiWay announcement and study, and the CUTRIC support is these first steps are critical. And I think after a fairly significant program in 2010 with Ballard, it's been long enough. So this first step towards scaling, this first step towards adding a complement, of a range extender to a battery electric, future as well. But again, I don't want fuel cell to be forgotten in that future. I think there's room for both. So this initial step of 10, not 1, but 10 with MiWay, I think is very significant for us to now break the ice. I had spoken at a conference with CUTRIC back in 2019 before all hell broke loose. And, we were talking hydrogen then and who would be the first and what would be the first big step. And I'm very happy to see it's Mississauga. And I really applaud CUTRIC for really supporting that effort. But if CUTRIC's ready, MiWay's ready, we're ready, Ballard's ready, I say, let's go.
Absolutely. Yeah, thanks, Kirk. And so, speaking of breaking the ice and, again, coming back to this idea of demonstrations of a particular scale, I think it'll be valuable also to really understand from the fuel supply side, especially for a green hydrogen supply chain, what do step-by-step increments of fuel supply, mean? And why are they really important? Why are they really important in the sense that you can't just ramp up to, let's say, a ton per day or 2 tons per day of fuel, but why start with, let's say, a 10 bus deployment? Why does it matter from the fuel supply side, Rob?
Yeah, thanks. I mean, I would agree with Kirk. I mean, I think 10 buses in terms of an initial fuel cell demonstration, and the focus on this is for a 12-year demonstration. So this is a very meaningful trial, both in the scale of it, but also the timelines. And just give a parallel example. I've talked about the Markham Energy Storage Facility that is being used to produce this hydrogen. I mean, that was a first of a kind demonstration project where Hydrogenics and Cummins developed the initial architecture for an indoor product platform that could be scaled to larger systems. You can't just think about it. right? Doing that project and proving it out first as regulation service, and now it's being used for blending of natural gas, and it's going to be used for providing fuel for the MiWay buses. That single project was the basis for Cummins to develop the Hylizer 1000 product platform, and in a short time was used by Air Liquide for the largest PEM electrolyzer plant in the world. So there's no shortcut here. And the innovation that will come on fueling infrastructure that we see right now, we're in a case where, unlike battery electric buses, the fuel isn't delivered to the door. So the fueling infrastructure for hydrogen needs to be built. We're looking at it on a project by project basis, but things like the distributed gas as a service network model, as we do infrastructure and lessons learned for MiWay and apply it to other transit agencies, and apply it to other truck fleets as well, you begin to build the infrastructure you need to move it forward. And we know that the scale economies come not just with 10 buses, but more like 20 and 30 buses. And more broadly, when you look at it across several transit agencies and more fuel cell infrastructure for trucks, it's a virtuous cycle, but we've got to get started. That's why this project is so important.
For sure. Thanks, Rob. And so definitely a bit more to unpack on the fueling as a service model that you mentioned there. But before that, a quick check with Parvathy here. Parvathy, from the point of view of an organization like CUTRIC, how do we come together with industry stakeholders such as New Flyer, Ballard, and Enbridge Cummins? And how do we support a transit agency? What difference do we make when we launch a 10 or 20 bus deployment like this? How are we helping the transit agency as well as the OEMs and fuel suppliers by launching a project like this?
That's a great question. Thank you, Soumya. So in terms of the role that CUTRIC plays, we are a national not-for-profit organization, which is having the vision to make low carbon smart mobility reality, and Canada to lead in that space as well. And we are also a member-based organization with innovative transit agencies like MiWay and industry partners like Ballard, New Flyer, and Cummins. So in terms of CUTRIC's role, we are facilitating energy transition to happen seamlessly and ensuring that it is something that is possible for our transit agencies to do. Because there is, when you actually look at it from the commercial lens, there are a lot of steps that an agency would need to pass through to actually reach a point of commercial readiness, to be able to purchase these assets, to be able to deploy them, collect data. There is a lot of work involved and a lot of knowledge involved in that. So CUTRIC comes as a facilitator, as the glue and the catalyst who is, making sure this project progresses and ensures that the funding gaps are solved, and ensures that the community in the country is getting the benefit of a zero emission technology deployments. And, while in doing so, we cater to our members' needs as well, and ensure that there is an economic, environmental, social business casing along with the, other pieces in terms of the policy. So that is the overarching role that CUTRIC plays. And as Kirk said, we are ready, everyone is ready. So let's go ahead and do it, is my point as well.
For sure. So, on one hand, there's strong signals that we are ready. However, it has taken a few years for us to get to this point. And we may take a little more time to actually get the buses on the ground. Our stakeholders here, especially our panelists here, they are quite privy to some of the challenges and opportunities that lie ahead in the Canadian landscape. To each OEM, there's a particular challenge that can still obstruct what they intend to achieve with this project and through other deployments. But as a stakeholder consortium, there's a whole different set of challenges to launch a project like this. So as a stakeholder consortium, I'll start off with Rob. As a stakeholder consortium, what are some particular challenges that you still see today? It's been a year since we last talked about this project. Have you seen an evolution in the technical, economic, and political landscape? Or do you see any particular challenges still plaguing the consortium that is trying to deploy this project?
Certainly that's a very broad question, but I'll just focus on one thing. I think you need a champion, and MiWay is a champion. They've had the vision. Joff Marinoff, the director of transit, has had a vision for 5 years of zero emission transit. They've done a lot of analysis, including the work CUTRIC has done with MiWay to identify that for their circumstances and longer routes and heavier passenger loads, that a fuel cell electric bus is a zero emission option that makes the most sense for them. It's the closest to a 1-to-1 substitution for diesel buses, their existing fleet. The challenge, as I mentioned, is the cost of the fueling infrastructure, because unlike a battery electric bus trial, we have to build the fuel. So MiWay is doing their investment in the buses. We've got the Zero Emission Transit Fund, the new fund, and that's new in the past year from the federal government, which goes a long way to paying for the incremental cost for the fuel cell buses and some of the associated costs. But we still have the cost and some of the fueling station costs. We still have the cost of the distribution. Now, Enbridge and Cummins for this project are looking to make a significant capital investment, to do the tube trailer filling and do the infrastructure. But in terms of what is required to pay for that and for have a reasonable cost of hydrogen for MiWay to run this run this project, there's additional funding required. So right now, that is the gap. It's sort of for the remaining of the fueling infrastructure required to get this project off the ground.
Sure, and well, just to add a bit more to that question, especially we've got an audience question, trying to wherein the audience members trying to understand what else can industry do at this point, and especially because transit agencies have a very specific challenge. They are used to 5 to 7 year fueling contracts, and I recognize that you touched upon it briefly there. Is there anything else that industry can do to support, hydrogen fueling costs at this point, or is it time for the government to step in? Is it that phase in the commercialization journey of any new technology where government intervention is very critical to get to the next stage?
Maybe I just want to add a comment here, Soumya. I think you highlighted, I think Rob highlighted very well some of the challenges. But one of them is, regardless you go to battery electric or fuel electric, there is a gap today, and the government is stepping up and providing funding. It's complicated in Canada between the provincial, federal, municipal, so it makes it complexity in Canada compared to US, where everything is run by the FTA. But also, I think the tools which are provided today might not be well adapted to hydrogen. I think there's a tool in terms of financing of infrastructure or financing of deployment of zero emission buses, which have been provided by, in addition to the incentive financing by the CIB. It's a great initiative. However, that tool was catered around battery electric, and hydrogen is a very different beast. Hydrogen is not regulated by utility, which in a way gives much more flexibility. It's much easier to do PPP projects on hydrogen production and distribution. So I think what we like is the government and the CIB and Infrastructure Canada to look at having a very specific set of tools which will help financing and incentive for hydrogen, which more only, as you mentioned, hydrogen production and distribution, to make sure that, with the flexibility of the business model, which we can bring with hydrogen, and also tapered on the development of hydrogen hubs across Canada. And we're going to see those hubs in different regions happening. So how do we link the deployment of hubs on the production of, increasing production of low carbon hydrogen in order to feed transit? So I think we need to adapt the financing tools so it could work for hydrogen. So I think that's very important because they give much more flexibility. It doesn't have to rely completely on government funding. I think today, private sector is ready to invest in the development of hydrogen production or low carbon hydrogen production at scale, but we need to enable that with the government support.
For sure. And so that said, I guess, are we going to be ready to scale after these first few demonstration projects? Are we ready to support maybe 10 other transit agencies in Canada after we get through these first few projects? Do we foresee any procurement challenges? I'll check in with Kirk. Kirk, as far as the assembly line is concerned and rolling out fuel cell buses is concerned, is New Flyer ready to scale? And like, how is New Flyer here for Canadian transit agencies to deploy buses at scale as soon as this demonstration is done?
Yeah, I mean, I agree with what Rob and Nicola offered in terms of funding and infrastructure. There's a lot of work there. I think there's more readiness on the part of the OEMs than there is on the infrastructure, frankly, to really help it scale, especially with battery electric struggling to scale maybe, which is why fuel cell, again, with scaling is a viable alternative. I think right now our biggest hindrance, and I think this is across the board, is supply chain issues in the wake of the pandemic, and that will hurt our ability to scale production slightly. So we've got plans, we will overcome it, but we're off to a slower start in 2022 than intended because of supply shortages, frankly, on all buses. And I'm sure that's quite common across the industry. That could slow deployment a little bit, but we're fighting back, and we know the world globally will recover, and we will as well.
For sure. Thanks a lot, Kirk. Actually, we do have some more tech specific questions coming in as well. But I think we may have to tackle some of those exchanges at the networking session in the afternoon. For the time being, because we're running out of time, I'd just like to do a quick roundtable and a quick fire. Any key messages, any final parting messages for transit agencies or our funding partners on projects like these? I'll just start off with Nicola. Any final quick fire messages for the audience here?
We are ready. We are ready to scale up. It's happening outside of Canada. It's happening in the US. It's happening in Europe. So it will happen in Canada. So industry is ready. We can scale up. We can deliver. Let's go.
For sure. Absolutely. Any final parting words there, Kirk, to add to Nicola?
Yeah, if anybody would like to know more or engage with us further in this discussion, we're very open to the discussion, and we can definitely offer even some training through our Vehicle Innovation Center. So that's open to all parties, and we can even talk workforce development. So reach out to us at any time. Thank you.
For sure. Thank you, Kirk. Rob, any parting words, especially on green hydrogen supply chain?
Just to echo, we're ready. The MiWay CUTRIC consortium is absolutely ready. This project is ready to launch, and certainly for any other groups that are looking for electrolyzers for a distributed gas as a service network or electrolyzers for a hydrogen hub, Cummins has a solution that's ready now for them.
Absolutely. And from the point of view, of the facilitating party and the organization supporting the planning and modeling, Parvathy, any final parting words?
Sure. I think the hardest part is the championship, right? To have a champion, to have a group of leaders, which we are, privileged to have. I think there is nothing stopping from, moving forward at this particular point. So I agree with the rest of the panelists here. Let's go forward and make hydrogen a reality in Canada.
Yeah, absolutely. And yeah, would be happy to answer more questions, especially the fueling side and also the bus operation side. Are big topics to unpack, and so would be more than pleased to answer specific questions based on lessons learned over the past year. We do have a substantial amount of lessons as we make progress on this project and approach the finish line. So yeah, please feel free to reach out to any of us, and we look forward to seeing you at the next panel. Thank you again to our panelists here for their continued support on the project and for these events, for these conferences. And thanks to the audience for joining us here. Goodbye for now.
Thank you.